How many users can your API handle right now? 50, 100, or 1,000? Today we are going to explore the key concepts of performance testing using a tool called K6. It's produced by Grafana Labs, and let me show you how to use it. K6 is an open source load testing tool created by the team at Grafana Labs. It's written in Go, but here's the cool part. You write your own tests in JavaScript. It's powerful and simple in the same time. And most importantly, it's based on the code that I can write on my own. Before we jump into K6, let's quickly cover the main types of performance testing, because knowing what you are testing is just as important as how you are testing it. Load testing. This is your daily traffic. Can your system handle your normal user load? Spike testing. What happens when you suddenly get 10 times more users? Think of a Black Friday traffic. Stress testing. Let's push the system until it breaks. Where's the breaking point? Endurance testing. Can your system handle steady load for hours or days without memory leaks? Alright, let me show you this diagram I created. This is going to help us understand the two main approaches to performance testing, and more importantly, when to use each one. First, let's talk about closed model, also called the virtual user model. The key question to this model answers is, how many concurrent users can the system support? And this is crucial for capacity planning. Why should we care about this? Well, imagine you are running an e-commerce site and you want to know, if 500 people are browsing my catalog at the same time, will the system handle it? Or will it crash and I lose all the potential customers? We have three virtual users: virtual user 1, virtual user 2, and 3. Each virtual user is like a person with a browser, constantly making requests to your API. They send a request, wait for the response, then immediately send another request. Let's say your business team says, we need to handle 100 requests per second, with a 99% of responses under 200 milliseconds. The open model lets you test exactly this scenario. Look at this example. I want 5 requests per second. If one virtual user can only handle 3 requests per second, because the API is slow, K6 will automatically create a second virtual user to handle the remaining 2 requests per second. The big difference. Closed model tells you how many concurrent users can I support, while open model tells you, can I handle this specific load under my SLA requirements? Both are essential, but for different reasons. This diagram shows something super important: system saturation. As we increase load, our system uses more CPU, memory, and network, disk, everything. Everything looks fine until boom, we hit 100% CPU utilization. Once we hit this saturation point, response times don't just get a little worse, they explode, they will raise immediately. Your 50 millisecond response time suddenly becomes 5 seconds because a request starts to queue up. The key is finding this point before your users do, and that's exactly what we are going to try to do with our catalog API today. So for this demonstration, we are going to restrict our catalog API's resources at the Kubernetes level. This way, we can actually see the saturation point and understand what happens when our system hit limits. Without this restriction, I would be just testing my PC full capabilities, so all CPU and all memory, and that's too much for a single application. All right, theory is great, but let's see this in action. I've got Visual Studio Code opened here, and I've prepared a simple K6 script that tests our catalog API using the closed model. Let me walk you through this script quickly. This script uses the closed model. So we are going to ramp up from 10 virtual users to 20 virtual users, then back down to 0. Each virtual user will continuously call our catalog API, just like real users are browsing product. I've set up some thresholds too. 95% of requests should be under a 500 milliseconds threshold, and we should have less than 10% of errors. If these thresholds fail, K6 will tell us that our test failed. This is how we define our SLA requirements right in the test. Okay, so let's run our script with a simple command of k6 run and then a file name of the script. And let's see what happens, what kind of results it will give us. Look at these 28,154 requests, 0 failures, and average response time of just 5 milliseconds. Our API handled 938 requests per second without breaking a sweat. This perfectly demonstrates this closed model concept from our diagram. Because our API is so fast, each virtual user could send multiple requests quickly. That's why 10 users generated nearly 940 requests per second. Okay, let's turn the heat up and make it 10 times more. So we'll have 50, we'll start from 50 virtual users and go to 100 virtual users over 10 seconds. And let's see what happens. We sent 26,719 requests, and that was 890 requests per second. So that's quite a lot. What else? We see that one of the checks failed. So we see 289 requests took longer than the 500 milliseconds, and that's why the check has failed. So it means that we are starting to see probably the saturation point, the maximum capacity of our system, and it wouldn't be able to process more requests per second, meaning we reached our peak point of the performance. What did we discover today? We explored the fundamental difference between closed and open models. We learned when to use each approach, and we successfully ran our first K6 test to understand our system concurrent user capacity. But here's the thing. Right now we are testing somewhat blind. We can see that response times are increasing and we understand the load patterns, but we don't know exactly why performance degrades. Is it CPU or it's memory or maybe a database? In the next episode, we are going to connect Grafana, Prometheus to our setup with K6. So we can see exactly what's happening inside our system. We'll identify the real bottlenecks, understand resource utilization patterns, and learn how to optimize our system based on actual data. Thanks for watching, and I'll see you in the next episode where we add observability to our performance testing and really understand what's happening under the hood. Thank you.